This is part 2 of absolute value functions. We're up to example 2. Example 2 says using characteristics to graph an absolute value function. All right, if you watched the first video, you know in example 1 they gave us an equation or a function, and we took that equation, made a table, and graphed it. This time they're only given as characteristics, and they want us to graph an absolute value function. So it's important to note that an absolute value function, remember it's a V-shaped graph or an upside down V-shape. So we know that's what we need to start with. We're going to end up with a V-shaped graph, and we have some things that they're giving us to start with. So it says f has a range of -infinity to 1. Remember, range is your y values. And a graph that is symmetric about the line x equals -2. Remember the symmetry, the line of symmetry goes to your vertex, so that's important to know. And has a y-intercept of -5. Remember, your y-intercept crosses the y-axis. So let's just focus on a part right now. So we have a range of -infinity to 1. We have a graph that is symmetric about the line x equals -2 and has a y-intercept of -5. All right, so -5 is the easiest one. Let's just go ahead and put that. So we're going to go 1, 2, 3, 4, 5. We're going to put a point here on our y-axis at it says -5, sorry. I seen that, and then I still went up 5. So we're going to come down 5. All right. All right, so a y-intercept of -5. So we've done that. And then we know the axis of symmetry goes through the vertex. So we know we have a vertex of -2 something. Well, the range is -infinity to 1. This is our y value. So it goes up to 1. So we can determine that that is our vertex. So we're going to graph -2, 1. Okay, so this is our vertex. And then we know the axis of symmetry goes through the vertex. So there's this imaginary line that cuts this V in half. So we can say this is 2 units from the axis of symmetry. If I go 2 units from the axis of symmetry in the other direction, there is going to be another point that goes with that. All right, so for A part, we use the axis of symmetry along with the range to determine the vertex, and we use the y-intercept and reflected the y-intercept across the axis of symmetry to get the other point, and that's how we graphed that line. So let's see. All right, trying to move that line just a tad bit. It's pretty close. All right, so that would be taking care of part A. All right, we could take this information and write an equation, but it just says to graph its absolute value function. So we're going to determine that A part is finished, and now we're going to look at part B. F is positive over the intervals -infinity to 0 and 4 to infinity. Negative over the interval 0 to 4, and the minimum value is -4. All right, a study tip. It says the interval in part A represents the y values. Why? Because it says the range is this, okay? In B part, the interval is your x values. It says f is positive over the intervals this and this. It doesn't say the range, so we determined that the intervals are always usually refer to the domain if it doesn't specifically say the range. And because the intervals are -infinity to 0 and 4 to infinity, we can conclude that our x-intercepts come from these points here. So this is xy, this is xy. So we have an x at 4. So we can graph that point. Let's go ahead and change colors here. So if we come out here, 1, 2, 3, 4, okay? Because we know it's positive over this interval and this interval, and it's negative over in between here. So we know that we're going to have this point here, so it's going to be 0, all right, so we know it's positive, meaning above the x-axis, and we know it's positive here. And between these points, it's negative. So that means the vertex is probably going to be down here. It also has a minimum value of -4. All right, if it has a minimum value of -4, 1, 2, 3, 4. So the minimum value is going to be in here somewhere. And if I look at these points, they're 4 apart, so I know the vertex has to be in between that. So that axis of symmetry is going to be halfway between the two x-intercepts. So you really have to think about what you're given and kind of piece the information together to use the characteristics to make a graph. But if you have 3 points, if you have a vertex and at least 1 point on each side of the vertex, you can graph that line. All right, so that one is how you would graph part B. All right, real quickly, if I lost you talking about the axis of symmetry, remember the axis of symmetry goes through your vertex and it cuts the absolute value in half. So that means if we have a point at 0 and another point at 4, the difference between 0 and 4 is 4 units. We know that that axis of symmetry has to go through that line, x equals 1. And it told us the minimum value was -4. So I put those two things together to determine the vertex. So that would be 2, -4, and that comes from your axis of symmetry and the minimum value. Example 3, modeling real life. The function m of x represents the absolute deviation in centimeters of a man's height x centimeters from the average height of men in Tennessee. The function w of x represents the absolute deviation in centimeters of a woman's height x in centimeters from the average height of women in Tennessee. A part says interpret and compare the vertices of the graphs in this context. And then it says compare the absolute deviations for a man and woman who are both 171 centimeters tall. All right, so let's just look at A part first. Interpret and compare the vertices of the graphs in this context. So let's look at men's first. So m of x equals the absolute value of x minus 179. All right, so we can conclude that this is in vertex form. So there's no a, there's no number in front of the absolute value. And then this would be h, and there's no k. So we can conclude that h is 179, his height is 179, and k is 0. So that would be the vertex. If you graph this function, hk would be your vertex. For women, we can conclude that it's also in vertex form. And the 163 would be our height. And our k would be 0 as well. So again, that would be our vertex on the graph. So if you wanted to graph these, you can use your calculator to graph an absolute value function. See if I can pull that up real quick. All right, if I say y equals, and I want to graph an absolute value function, I've got, let's graph the women first since it's easy to see here. So I've got, if I go to math and I arrow over to number, ABS is my first button there. So that's absolute value, and I can graph x minus, well, let's do 179 first because that is the men's. I can see part of the function here. So x minus 179. So y equals x minus 179. That represents the men, And then if I go back to math, over to number, absolute value of x minus 161, and then arrow outside my absolute value, and then hit graph. And again, we may have to change the window. So I'm going to turn off my stat plot. Let's turn off my stat plot. So if your window's not correct, it doesn't even look like a V-shaped graph. So you have to have your calculator set up. Let's turn off the stat plot. That's going to take the points away from the last lesson. And now we need to do something to our window. So what do we need to do to our window? We know the vertex is going to be at 179 and 163. So our vertex is, this is going to be on the X and this is the Y. So we need to come to our X's, and this says X is a maximum of 55. That's why we couldn't see a V-shaped graph, because the vertex is where the axis of symmetry is. So we need to have, let's say 200. We need a number bigger than either one of these. All right, and then our Y value, I don't guess it matters what our Y value is. So let's go back and change our scale. Since this is 200, let's change this to 10 as well. All right, so the Y's, it should be fine. Let's graph this, and now we should be able to see the vertex of both of these graphs. Okay, and if you have forgotten, you can go back and look. Blue, this is the men, blue is men, and red graph represents the heights of women. All right, so what does that really tell us? So that tells us that there are 16 units between here and here. So if you look at 163, the difference between 179 centimeters and 163 is 16. So there are 16 centimeters greater. So that means, what does that mean? That means that the average height of men in Tennessee is about 16 centimeters greater than the average height of women in Tennessee. All right, so when it says interpret and compare, that would be our comparison, is that men are on average 16 centimeters taller than women in Tennessee. Now we want to compare their absolute deviations for men and women who are 171. Okay, so if they're about 171 centimeters, we can just plug that in for X. So let's check the men first. So we're going to say M of X equals 171 minus 179. And that's going to be 171 minus 179 is negative 8. And the absolute value of negative 8 is 8. Let's do the same thing for women. All right, we want to check when a female is 171 centimeters. Let's subtract 163. All I'm doing is taking the number they gave us right here and plugging it in for X here and here. So M of X, I plugged it in right here. Now W of X, I'm plugging it in here as well. So I've got 171 minus 163, so that would be 8. And the absolute value of that is 8. So we can conclude that the heights of the men and the women are both 8 centimeters from the average height. Now, if you look at that picture, it looks like that is not 179. Hers might be slightly above 163. Maybe they're slouching, I don't know. But anyways, that picture is not really to scale, so just be aware of that. But compare the absolute deviations for men and women, okay, who are both 171 centimeters. They would both be 8 centimeters from the average height of men and women in Tennessee.